Today's topic, we are doing 2.3, which is converting between fractions and decimals. Our learning goal, I can convert between different forms of rational numbers. So let's get started. Because you can divide any integer by any non-zero integer, you can use long division to write fractions and mixed numbers as decimals. These decimals are rational numbers and will either terminate or repeat. So a terminating decimal is a decimal that ends. Some examples would include 1.5, 0.25, negative 0.25, 10.824. So they have an ending. Those decimals stop. They don't go on forever. So a repeating decimal is a decimal that has a pattern that repeats. And some examples of this would be 1.3 repeating. So that's like having 1.33333, and it goes on forever and ever and ever. We write it as 1.3 and we put this little bar above it. Another example would be 0.12, 1212. So if that goes on forever, we write that as 0.12, and the bar goes above the 1 and the 2. So this little bar here is called bar notation. And those go over the numbers that repeat. So it goes over the numbers that repeat. So if the 1 and the 2 repeats, it goes over the 1 and the 2. If it's just like a 3 repeating, then we just place it over the 3. This 1 at the beginning of 1.3 repeating did not repeat. It only happened once, so the bar is only over the 3. We also never extend the bar over past the decimal. It always stays behind the decimal. So how do you convert a fraction to a decimal? We take the numerator and we divide it by the denominator. So this is taking the top of our fraction divided by the bottom number of our fraction. So in order to do this, we have to use long division. And so we have 5 over 11. So we take our numerator, which is 5, that goes on the inside of our long division bar. I'm actually going to write this down here. And the 11 goes on the outside. And so when we do this, 11 doesn't go into 5 evenly. 11's too big. So we put a decimal and then we put a 0. 11 goes into 50 4 times, but this 4 went above the 0. So we put a decimal, put our decimal above, so they are always lined up together. And then 4 times 11 gives me 44. So that is what we're going to subtract from 50. So when I subtract, I have to borrow. This becomes a 4 now. And this becomes 10. 10 minus 4 is 6. 4 minus 4 is 0. 11 doesn't go into 0, so we have to place another 0, and we bring it down. So now we see how many times does 11 go into 60? 11 goes into 60 5 times. 5 times 11 gives us 55. We subtract those two numbers. When I subtract those, I have to borrow, so that turns into a 5, and then we have another 10. 10 minus 5 gives me 5. And then 5 minus 5 gives me 0. 11 does not go into 5, so I'm going to put another 0. And you kind of can start seeing that pattern happening. So now, let's see, we have 11 goes into 50 4 times. 4 times 11 is 44. Subtract again. We have to borrow again. Oh, so that becomes a 4. This is now a 10. 10 minus 4 is 6. 4 minus 4 is 0. And we're kind of starting to see that same pattern. We had already subtracted and got a 6 before. So when we bring down another 0, we get the same thing. So 11 goes into 60 5 times. 5 times 11 is 55. Subtract, and we'll end up getting 5 again. So we can see that pattern happening, and it's just going to continue forever. And so when we write this, 5 over 11 is equal to 0.45, but the 4 and the 5 keep going forever. So we're going to put that line above the 4 and the 5. And that's my answer. So let's do another one. So we have 4 divided by 33. Well, we know that it's going to stay negative because all we're doing is rewriting this number as a negative or as a decimal. And so since we're just rewriting it as a decimal, that negative is going to stay. So we are going to take 4, and that's on the inside, and we're dividing it by 33. 33 does not go into 4, so we're going to place that decimal into 0. We might have to extend this line a little bit. So 33 goes into 40 one time. But remember, we have to keep that decimal aligned. So 1 times 3 is 33. We're going to subtract. We're going to have to borrow. And so 10 minus 3 is 7. And then 3 minus 3 is 0. We do not have 33 does not go into 7. So we have to add a 0, and we'll bring it down. 3 goes into 70 2 times. 2 times 33 is 66. I'm going to subtract. When I subtract, I'm going to have to borrow. So this turns into a 6. And now we have 10. 10 minus 6 is 4. And then 6 minus 6 is 0. So now again, I'm going to add another 0 and bring that one down. And we see that pattern happening again where we have 33 goes into 40 one time. 1 times 33 is 33. When we subtract, we've already done this, but we have to borrow again. So 10 minus 33 is 7, and 3 minus 3 is 0. And again, you can see that pattern starting to happen. And so we get 70 again, and that happened up here. And it's happening again down here. And since it's happening multiple times, we know it's going to repeat, because then we're going to go, 33 goes into 70 2 times. 2 times 33 is 66. And we get 4 again. And so this 1, 2, 1, 2, that's going to go on forever and ever and ever. And so we have a decimal of 0. Remember, 0 goes here because 33 did not go into 4. So we have, I'm put this in black. So we have 0 with our decimal. And then we have 1, 2, and that 1 and 2 repeats. And so this is our answer for our second one. All right, so when we have a mixed number, we need to turn this into an improper fraction. So to do that, we multiply 2 times 4, so our denominator times our whole number, and then we add our numerator. So 2 times 4 is 8, plus 1 is 9. So this is the same as 9 over 4. And we keep our negative because it was originally negative. So now we need to turn this into a decimal. So 9 goes on the inside, 4 goes on the outside because 4 is our denominator. 4 goes into 9 2 times. 2 times 4 is 8. When we subtract, we get 1. I'm going to add a decimal and a 0. And then I put my decimal right above it because we always line those up. And I bring down that 0. 4 goes into 10 2 times. 4 times 2 is 8. Now this one we're going to want to keep going because we need to make sure that it doesn't end. So 10 minus 8 is 2. And so now again we're going to bring down a 0. 4 goes into 25 times. 5 times 4 is 20. When we subtract, we get 0. When we get 0, that means that it's over and it has an ending. So this fraction, or this decimal, is a terminating decimal, while these two had patterns that went on forever and ever and ever, so those were repeating decimals. So when I write this is equal to negative, don't forget that negative, 2.25. So now I'm going to have you do the try-its on your own.